So today, here's what we're going to do. I'm going to get, you don't need to draw this, but I'm going to say I have a parabola, and it touches the x-axis here and here, and it looks like this. What's the equation of the parabola? And that's what you guys are going to do. You're going to find the equation of a parabola by me giving you the roots. Now, the trick is I actually have to give you a little bit more than that. I have to give you at least one other point. Okay? But that's what we're doing today is we're going to find the equations using roots. Why do we like to find equations in math? Well, math is all about using numbers in a logical way to solve real-life problems. So equations are really useful because it's like a machine where you can plug something in and get an answer out. So if you have like a real-life scenario and you can somehow turn that into an equation, then you can predict what values will occur at certain points in time. So in this case, I'm going to show you one way you can find an equation, and that's by if you know the roots of a quadratic equation. And quadratics are very useful. You're in physics, and if anybody else turns up in physics, you'll find that quadratics are very useful for anything pertaining to gravity. So let's take a look. Now, you don't need to write this. I just want you guys to watch, okay? We learned this on Tuesday. Finding the roots by factoring. What do you do first?
You bring the sum to the other side.
There's the right answer. You plug 0 in for y. Now what?
Then
you do the box and you factor it. Now I'm going to be lazy. I'm not going to actually do the box, but I will show you what the answer would be. If I did the box, I would get that. We've done that, Micah. All right. Now what do we do? Yep. You take each piece and set them both equal to 0, right? Bonus point. What do we call that? When you take each piece and set each piece equal to 0. Well, give me a hand so I give you points. Yeah? Woo! Close enough. I'm going to give it to you. Zero product property. It's called the zero product property. All right. And then we solve it, right?
Yeah, so
there you go. That's what we learned. So that's how you can find roots when it's in bonus point. What do we call this?
Oh, that's
yes?
Oh.
Standard form. Nice job. Okay. That was very kind of you. All right. That's how you find the roots when you're in standard form. Actually, what's another way to find roots when you're in standard form, though, if factoring isn't? Okay, Joanne, go ahead. Quadratic formula. Quadratic formula. But we learned this one. Now let's see what we're going to do with this. Today, our job is to work backwards. I'm going to give you the roots, and you have to find the equation. But let me show you. It's really not that.
Did you lock the door?
No, I didn't lock them. I put my little magnetic strip in to keep the door unlocked. All right. So, guys, if these were my roots, then what did I have before that?
You had the x minus 3 and x plus 4.
Very good. Now, if I had x minus 3 equals 0 and x plus 4 equals 0, what did I have before that?
X minus 3 and x plus 4. X minus 3 parentheses and x plus 4 parentheses.
Good job. Now, this is interesting. What would I do here?
The box.
Box, but the other way. Instead of factoring, we multiply it in, right? So what you would do is you would go, okay,
Would you use PEMDAS?
these are my answers, right? And you would multiply to fill in your box. Right? I'm not going to do the whole thing, but that's what you would do. One more thing.
Just change it to y.
And there's the original equation.
That's it?
Yeah, I mean, there's going to be a little bit of an extra thing in there, and I'll tell you why in a second. But for now, if you know your roots, that's what you do to work backwards to find your equations. Now, let's talk about that little extra thing. You guys remember how I told you that if you know the roots, in this case, it's 3 and 4. So I've got a root here and here. Don't you guys agree that could be my parabola right there?
Yeah. Yes,
Oh, is it -4?
Yeah.
Sorry. So scribble that out. We still have a root here at 3. but now our roots are here. So don't you guys agree it could look like this?
Yeah.
But couldn't it also look like that?
Yeah.
So there's more than one parabola that could actually have those roots, and each of those would have a different equation. So actually, what I need to do is I need to give you at least one more point, and you'll see what that other point does, but basically it narrows down your options. So let's go ahead, and it could be a y-intercept, but it could be really any point technically. So let's go ahead and write down this. This is very important. Write down your title and the problem there. Or not the problem, but the formula. This is what we're going to use to find the equation of parabolas when we have our roots. So here's how this is going to work. I'm going to tell you guys the roots of a parabola, and you're just going to put the roots into this little formula. Okay? Remember how last time we had 3 and 4, right? And then you guys knew that, oh, that means it must be x plus 3, x plus 4. That's what this is. It just basically does that word for you. So you just put those numbers in there, but the signs become opposite. Remember back here in our example that we did, I'll back up a little bit, we had 3 and we had 4, but when you guys wrote it like this, notice how the signs changed? Okay, same thing here. So you're going to put your roots in there, but the signs are going to change, right? Now you might be wondering what's up with this A, and that A is the thing that determines which way your parabola goes. Remember I said there could have been 2 possibilities? The A is the one that does that, and that's why we actually need one more point. But you'll see when we actually do an example. But this is our formula we're going to be using for the day. So let's see how this works for us. Go ahead and write down your directions here in number 1. I'm going to plot these points. Now, you don't have to do this, okay? I'm just doing this to help you guys notice something, okay? Well, let's graph these points. Negative 2, 0, that's going to be here. Negative 1, 4 would be up here. And then 3, 0 would be here. Now, if I were to draw a parabola, it would look something like this, okay? Now, my reason for drawing that is to help you guys identify which numbers are your roots. Which numbers are the roots? Good. I heard 2 good answers. One good answer I heard was the ones that have zeros on them, right? But you want to be a little bit more specific. You're right. That's my root, and that's my root, the ones with zeros. But it has to be which part is 0? The y, okay? There is a homework question where I give you a third number with a 0 for the x. That's not a root. So whenever you have a 0 on the y, that's a root. You could tell from your graph here, though, because it's just that number there. So it's negative 2 and it's positive 3. So what I want you guys to do is I want you to label these. We're going to call this one root 1, and we're going to call this one root 2. No, Hannah. No. Hannah. All right. Now, I'm going to label these 2 as well. I'm going to call this one just x and this one y. Isn't that fair to say?
Yeah.
Okay. Let's go to our little formula that we just copied down in the last slide. We have this, right? What we're going to do is we're going to plug in everything that we know. There's only one letter we don't know. Which one do we not know? We don't know A. So our first job is to find the A, okay? So here we go. Leave the A alone. What is x? What is R1? What is x? It's negative 1, right? Same thing. Minus what's R2? What's y? 4. Okay. Now, we're going to simplify this and this separately. So, first of all, double negatives becomes a positive, right? And what's negative 1 plus 2? It's 1. And what's this going to make? And what's negative 1 times negative 4? Now, this is important. I don't want you guys to write this, because that looks like A minus 4, doesn't it? But it's not A minus 4. What is it? It's A times negative 4. So you know how we write it? You could put parentheses, but I'm just going to write it like this. Okay? But you could say A parentheses negative 4, but don't put A minus 4, because that's wrong. Okay? So you can either put A and then parentheses minus 4, I'm sorry, negative 4. Or you can put negative 4a. I like this one better. All right, now what do I do to find a? So now I know the a. Why do I need the a? Remember, I told you the a is the number that tells you what, remember when you have two roots, you can have different parabolas going there, right? So now that I know what a is, I know it's a sad face parabola, right? If it was a positive a, I would have a happy face parabola. All right, now I'm not done though, because what is this question asking for? The equation. Is this the equation of a parabola? No, that's the a value, right? So this is step 1, okay? So I'm going to label this as step 1, and we're going to, what did we do here? Basically, we solved for a. That's the first thing you need to do is find your a value. So plug in all your numbers and find a. That's step 1. Good?
No.
All right, step 2.
You plug in.
Yes, we're going to plug in 3 things. We're going to plug in A, R1, and R2 back into that formula again. Ready? So what is A now?
-1.
-1. Did I say plug in X this time?
No.
No. So leave X, but I am going to plug in R1. What's R1?
-2.
Okay. And am I going to plug anything in for X?
No.
What's R2?
3.
So we don't plug in those.
3. Yeah.
Not this time. And did I say plug anything in for Y?
No.
No. Why do I not want to do that? Well, right now I'm trying to answer the question. The question is find the equation, right? And when you have an equation, don't they usually have X's and Y's in them? So you leave the X's and Y's alone. I'm going to grab that phone. I'll be right back. Hey, it's Bailey. Yes. Okay. Now let's go ahead and keep going. I'm going to simplify this as +2. You guys good with that? Yes, Mr. Bailey. Good to hear. Glad you guys are good with that. All right. Now we need to do step 3, which is to multiply everything together. Yeah. So step 3. Let's distribute and multiply. Bless you. Distribute and multiply. So first of all, let's start with the -1. I'm going to go ahead and distribute that -1 into here. You're not going to do it to both, okay? If you do it to both, then you're double multiplying. Don't do that.
Use the one. Or do I have to rewrite that?
That's up to you. I like to rewrite it just for the sake of notes, but if I were actually solving the problem out, I would not rewrite it again. All right, so you're going to distribute, but you only do it to the first one. Don't double distribute. Okay, so that's going to be -x minus 2. You guys good? Now, how do we do this? No PEMDAS.
Equals 0?
Nah. That's if you're trying to find roots. I want to multiply those together. You guys remember how to multiply 2 by 1?
Box.
Box method.
Oh, man.
I apologize. I was very loud box.
You know what? I appreciated the box answer, even if it was a little loud. Okay, so let's do it. What's this going to be? How about here? Here?
3x.
And then we're going to combine these, right? So it's going to be -x squared. And what's 3 take away 2?
So x.
That's the equation.
Oh, wow.
Okay? So this is the parabola that has the roots -2 and 3, and it goes through that point.
So we're pretty much doing what we did
Backwards. Backwards, yeah. No, not according to what I have here. I have a negative times a negative.
I know, but like it was a positive 3 to begin with, and so it would have. So it would have become it was a positive 3, and when you input it, it becomes a negative 3. But then you multiply everything by -1, and that.
I should know. All right.
Quick enough.
All right. Guided practice time. Write it down. All right. So here's how you properly label them. R1, XY, R2. Now I want you guys to do the next thing, which is plug it in and solve for A. Go for it. I'm going to give you guys probably about maybe a minute and a half for that one. Okay.
Versus R1 and R2, are we not swap it?
Yes.
Okay.
It does. I am. We're doing step 1.
Oh.
All right. So what did you get, David, for A? Yeah. That's a good start. You're probably right. But I don't think you've found A yet. So I want to know what A is. What does A equal? Micah? Close.
-2.
Isn't it -2?
Yeah.
Okay.
Oh no, I got positive 2.
I got negative.
Okay.
4 is negative.
Let's see. I'm hearing mutiny here. So I'm assuming I'm wrong. So positive maybe? No. I'll work it out. Let's do it. So we have A, and then we have X minus R1, and then X
2 minus 4.
minus R2 equals -4. Oh, there it is. There's that. I missed that negative there. All right, so we have A times 1.
So it is positive 2?
Yeah, because this guy right here is -2. And so when we multiply these, you get -2A equals -4. So when you divide it, the negatives cancel, and you do get a positive 2. So, good?
Wait.
I'll leave it. Now I want you guys to do the next step. Okay? Good.
Oh, wait. That's where I messed up. Oh, yeah.
Do your next. Okay. Next, Kayla, what do I do now? You do the box. Okay? There you go. Here's your final answer.
I got it right. Proud of myself.
Okay. Now I'd like you to try one more for the bell rings today, but this one I want you to do from beginning to end. I'm just going to ask you for the final answer, okay? And that's the end of our lesson, so do that one.
I don't know.